Question 1. Is Node.js entirely based on a single thread? Yes, it is true that Node.js processes all requests on a single thread, but it is just a part of the theory behind Node.js design. In fact, more than the single thread mechanism, it makes use of events and callbacks to handle a large number of requests asynchronously. Moreover, Node.js has an optimized design which utilizes both JavaScript and C++ to guarantee maximum performance. JavaScript executes at the server side by Google Chrome V8 engine, and the C++ libov library takes care of the non-sequential I/O via background workers. To explain it practically, let's assume there are 100s of requests lined up in Node.js queue. As per design, the main thread of Node.js event loop will receive all of them and forwards to background workers for execution. Once the workers finish processing requests, the registered callbacks get notified on event loop thread to pass the result back to the user. Question 2. How does Node.js handle child threads? Node.js is a single-threaded language which in background uses multiple threads to execute asynchronous code. Node.js is non-blocking, which means that all functions, callbacks, are delegated to the event loop, and they are, or can be, executed by different threads. That is handled by Node.js runtime. Node.js primary application runs in an event loop, which is in a single thread. Background I/O is running in a thread pool that is only accessible to C/C++ or other compiled or native modules, and mostly transparent to the JS. Node versions 11 and 12 now has experimental worker threads, which is another option. Node.js does support forking multiple processes, which are executed on different cores. It is important to know that state is not shared between master and forked process. We can pass messages to forked process, which is different script, and to master process from forked process with function send. Question 3. How does Node.js support multiprocessor platforms, and does it fully utilize all processor resources? Since Node.js is by default a single-thread application, it will run on a single processor core and will not take full advantage of multiple core resources. However, Node.js provides support for deployment on multiple core systems to take greater advantage of the hardware. The cluster module is one of the core Node.js modules, and it allows running multiple Node.js worker processes that will share the same port. The cluster module helps to spawn new processes on the operating system. Each process works independently, so you cannot use shared state between child processes. Each process communicates with the main process by IPC and pass server handles back and forth. Cluster supports two types of load distribution. First, the main process listens on a port, accepts new connection, and assigns it to a child process in a round-robin fashion. Second, the main process assigns the port to a child process, and child process itself listen the port. Hit the like button and subscribe for more useful questions and answers for your job interview preparation. Question 4. Since Node is a single-threaded process, how to make use of all CPUs? A single instance of Node.js runs in a single thread. To take advantage of multi-core systems, the user will sometimes want to launch a cluster of Node.js processes to handle the load. The cluster module allows easy creation of child processes that all share server ports. Please look at the example below. Running Node.js will now share port 8000 between the workers. The worker processes are spawned using the child process fork method so that they can communicate with the parent via IPC and pass server handles back and forth. The cluster module supports two methods of distributing incoming connections. The first one, and the default one on all platforms except Windows, is the round-robin approach, where the master process listens on a port, accepts new connections, and distributes them across the workers in a round-robin fashion, with some built-in smarts to avoid overloading a worker process. The second approach is where the master process creates the listen socket and sends it to interested workers. The workers then accept incoming connections directly. Question 5. If Node.js is single-threaded, then how it handles concurrency? Node.js, despite being single-threaded, is the asynchronous nature that makes it possible to handle concurrency and perform multiple I/O operations at the same time. Nodejs uses an event loop to maintain concurrency and perform non-blocking I/O operations. As soon as Node.js starts, it initializes an event loop. The event loop works on a queue, which is called an event queue, and performs tasks in FIFO, aka first in, first out order. It executes a task only when there is no ongoing task in the call stack. The call stack works in LIFO, aka last in, first out order. The event loop continuously checks the call stack to check if there is any task that needs to be run. Now, whenever the event loop finds any function, it adds it to the stack and runs in order. Please look at the example below. Here, the function print5 will be invoked and will push into the call stack. When the function is called, it starts consoling the statement inside it. But before consoling the whole statement, it encounters another function, add with n and n parameters, and suspends its current execution, and pushes the add function into the top of the call stack. Now the function will return the addition a plus b, and then popped out from the stack. And now the previously suspended function will start running and will log the output to console, and then this function too will get popped from the stack, and now the stack is empty. So this is how a call stack works. Question 6. How to kill child processes that spawn their own child processes in Node.js. If a child process in Node.js spawns its own child processes, the kill method will not kill the child process's own child processes. For example, if I start a process that starts its own child processes via child process module, like in the example below, killing that child process will not make my program to quit. The program above will not quit if my command spins up some more processes. Look at the PID range hack. We can start child processes with detached true option, so those processes will not be attached to main process, but they will go to a new group of processes. Then using the process kill method with -pid parameter, on main process we can kill all processes that are in the same group of a child process with the same PID group. In my case, I only have one processes in this group. Please note the dash before PID. This converts a PID to a group of PDs for process kill method. Hit the like button and subscribe for more useful questions and answers for your job interview preparation.